All right. Good morning, everybody. Looks like we are all, I think everything's all set, all ready to go. Okay, welcome on in. So we're here for Applied Calculus, Math V46, having our weekly meeting here. So a few things to get through before we dive into the material. Let's see, a couple things I wanted to go over. So one is the schedule. So remember, the class schedule is super easy to find. Not the class schedule, the academic calendar is what I meant to say. Oh yeah, and thanks for the people, especially on YouTube, that are throwing your names into the chat. That's going to make it a lot easier here in 5-10 minutes when I take roll. So thanks for doing that. Right, but then we are about to take a transition in this class in a few ways. So let's discuss those. So remember, if you're on the main Ventura College webpage, let's see, if you're right here, you just go up to academic. Oh, it's not quite on there. Academic calendar, and you can get all those calendars that you need: final exam schedule, academic calendar, all that kind of good stuff. So if you're like, when was the final, or when is this supposed to happen? Do we have a holiday next week? What's going on? You can look all that up very easily, right? So looking at that, we see that today is what, February 8th. Okay, so this is the 8th. So this is our last meeting, unless something crazy happens. This is our last meeting online. Okay, so remember, this is this course was put in the schedule as an on-campus class. We will begin meeting in Science 353, just as the schedule states, starting next week. So you may or may not have seen the emails that the school has sent out. They generally go to your Ventura College email address, which many people don't ever check the whole time they were students, and some people don't even know they have a school email. But that's where the school is contacting you. That's how we get a hold of you, right? So sometimes students will, I'll have a student that's like, what? I don't even know what you're talking about. Well, because you don't check the email that the school notifies you things about. So when you originally signed up for this class, it was an on-ground class. Because of the spike in Omicron, things got pushed to, let's see, where do I turn the sound off again? Meeting settings, sound off. Okay. Because of the spike in Omicron, most of the colleges in the state decided to just wait, let things die down, which they are doing. The numbers are starting to come down. Number of infections is coming down. The hospitalized is still up because hospitalizations lag behind infections by a couple of weeks. But we should start seeing a reduction. So we will, the next time we meet, we'll be in the classroom. There will no longer be a Zoom meeting. This is was originally supposed to be an on-ground class, and the next time we meet, it will be an on-ground class. I do not have the facilities to stream our class meetings in the classrooms. Okay, for the last few years, I spent quite a bit of money setting up a streaming setup at home so I could stream for the classes and then stream for my own reasons when I do stuff. So I have a really good setup for doing different things and being able to handle things at home, but I don't have that in the classroom. We do have some technology. You may have had a teacher that streamed from the classroom, and we've, the school tried things, setting it up so you could have some people in the class, and then you could also put the meeting online. And they were disasters. They were just terrible. People that were in the classroom couldn't understand people that were on the Zoom meeting, and then like trying to communicate. It was just a big failure. So we tried to make something like that work. It was a monumental failure. So when we go back to the classroom, we are in the classroom. That's if you're not in the classroom, you will be missing hours of instruction. You will be missing your opportunity to get your questions answered, at least in person, right? You can still, there's still the tutoring center, there's still office hours, but you will be missing that instruction. You do have the videos on Canvas, but that's not really good enough, right? That's the whole reason we're meeting, right? A lot of times students will ask me like, well, do I need to do this? But if you think about it, that question is kind of a little bit silly. I even got one of those emails this morning like, well, what if I just skip the homework for a certain chapter? Is that gonna hurt me? Well, yeah, that's the whole idea, is like I'm giving you stuff that's going to help you understand the material. If something wasn't necessary, I wouldn't have you do it, right? It's not just that I want you doing work. I want you doing work that helps you progress in the class. So anything related to the class that you don't do is now setting you back significantly. And I can tell you, missing classes sets people back significantly. So please be prepared for Tuesday, that you can come on campus and you can participate in the classroom. They even have at the top of this page, right? I'm thinking of the previous page. This one over here, it's even got the, or did they change it? Oh, they changed. Did they? Let's see. Oh, no, here it is. Wristband and mask, right? You see huge lettering. Before coming into your office, please make sure you have your wristband and mask. That's also the classroom, right? So you have to understand that wristband and mask have to be in place, or you will not be in the classroom. You will be asked to leave. So, and it's not my call. I agree with it. I think it's a good policy, but it's not like I can make an exception for you. And I know I've said this before. I'm just making it clear because we're about to do it. And I think there could, hopefully there won't be any rough spots, but I think, by and large on the school, there's going to be some rough spots on next week when everyone's coming back. Hopefully not in my classes. So I don't get to make the decision about like, oh, you didn't get your wristband. It's okay. You can stay in the classroom. The school policy is if you don't have a mask or you don't have a wristband, you do not get to be in the classroom. Okay. So, and I'm already sort of suspecting I'm going to hear, oh, but I'm vaccinated. I just didn't get it doesn't matter. Like, we can't see inside your body. We don't know if you're vaccinated or not vaccinated. You have to upload that vaccine card to the school's app. They have to approve it. And then, which, if it's a legitimate card, they're going to approve it. And then you can come to campus. And I wouldn't upload the morning of the class because I imagine there's going to be thousands of students uploading their card that morning. And I don't know how long the process takes for them to vet them all. They haven't told us how that's going to work. So if you have your vaccine card and you got your shots, just upload it now, right? Then you won't have any problem coming in on Tuesday of next week. I don't know what the parking situation is going to be. We have a lot less class meetings are taking place. Like this class used to meet 2 times a week. We're meeting 1. There's a lot of classes like that are like, this is considered a hybrid course. It's partially online, partially on ground. There's a lot more just online classes. So it might not be as crazy on day 1 back as it has been in the past. Like it's essentially the first day of school, right? Everyone's kind of showing up at the same time. It might not be as crazy as it used to, but it might be packed, might be hard to find parking. We don't know. This is the first time we've done this under these conditions. So, don't plan on pulling into the parking lot at 9:59 and think it's all going to go fine, because it isn't. You will be late to class. Let's see, there's a question here. If we already uploaded the vaccine card last semester, do we have? No, good question. So basically, if you uploaded, like I uploaded my vaccine card like last summer, and I'm still good to go. So if you already uploaded your vaccine card and you got the both shots and there was no problem with your vaccine card, you're good to go. That's good. You took care of that. That's great. So then you don't have to worry about it. There was a really good question that a student asked me about the booster. The district has not indicated anything about the booster at this time. It is likely that in the future, we'll probably see this coming down the lines at the UCs and the Cal States first, where they're probably going to start implementing, okay, now you need to have the booster on your vaccine card. And once they do that, it's entirely likely that we are going to follow suit. That's kind of where people think it's going to go. But that has not happened yet. So you just need those 2 original shots. You need your card that indicates you have those 2 original shots. You just go into the VC app. I think and it has a button there for like your vaccine card or whatever it is. And you take it, you push it. And if I remember right, you just take a picture of it right in the app, and then it uploads it. School looks at it and says, yep, looks legit. And then you're good to go. So, what'll happen then is when you get to school, you have to open the app, and it says like daily screening, I think, or something. Forget exactly what it's called. I think it's called daily screening. It'll ask, do you have any of these symptoms? right? Obviously, if you have the symptoms, you should say you have the symptoms. If you don't have the symptoms, you say no symptoms. And then you go to the next screen and ask if you've been exposed to people who have known people to have COVID. If you answer honestly to all these questions, but if the answer is no, then you hit no. And then it gives you a little blue, like kind of, I don't know, digital card at the top, whatever you want to call it, little image. If it's blue, that means that you've been vaccinated and you're approved for the day to come on campus. You go to one of the screening centers. You'll be able to see these because they have like the tents. So there's one kind of over by the El Camino building, at least where they've been having it. I don't know. I'm sure they're still going to have one in that parking lot, but it's over kind of by El Camino in the west lot where they do the market on the weekends. And then there's one kind of by the orange, that weird orange building in the front of the school. There's one over there. That's actually usually the one I try to go to. It doesn't matter which one you go to. You show them your phone with that little blue rectangle picture on it. It's not really a picture, but it's not really just text either. And they'll just put a wristband on you, and then you come to class. So if you've done all the prep, it's kind of like the class, right? If you've done the prep work, then there's no problem. If you haven't done the prep work and you're not prepared, then you're going to have all sorts of problems, right? So just make sure you've taken care of everything ahead of time. Give yourself an extra 10 minutes to get to class. Try to be getting out of your car 10 minutes, maybe 10 to 10. Maybe even 15 minutes before 10. That's going to be kind of a prime time on Tuesday. 10 o'clock is the most popular time for classes. So, you might find yourself in a big line if you're not even a little bit early. Sometimes that's how it happens at college. Like, this happens in life, but also in college. Like, if you do stuff like just a couple minutes before you have to, you're in a group of like a ton of people all trying to do the same thing. But if you're even just like 10 minutes early, sometimes you miss the whole crowd because 95% of people are trying to do it at the last minute. So it only takes you like being 10 minutes early sometimes to miss the entire like crowd. And then, you showed up 10 minutes early, but you save yourself 20 minutes of standing in line. So and then you come to class. So like I say, if you don't have a mask, you can't stay in class. I have to tell you to leave. If you don't have your wristband, like I have to have a wristband just as much as you do. I can't like tell myself, it's okay, I'm running late, I don't have to get a wristband. If I'm seen without a wristband, they'll send me home or they'll send me to go get a wristband, right? So you have to have those things. If you are exhibiting sick behavior in class, I have to ask you to leave. So if you show up in your coffin the whole time, sorry, I have to ask you to leave. Part of my job is to maintain safety in the classroom and make sure people aren't getting infected. We are having a bit of a heat spell right now. We're expected to potentially break heat records the next couple of days, for at least for this part of the year, right? For this time. When we meet in classrooms, I likely will be opening windows up so that we can get ventilation in there, so that we're not spending 2 hours breathing each other's exhaled air and potentially, spreading the virus. Because no matter what you do, there's people who are asymptomatic, have no idea that they have COVID, and they still come in because they don't know they have it, right? If you're asymptomatic, it's pretty hard to know you have it, so that's no guarantee against spreading it. So windows will be open, so if whatever the temperature is at that time, dress accordingly. If it's, cold that day, bring a hoodie. If it's warm that day, then wear something, where you won't overheat. But do realize we have to maintain safety in the classroom. You have to have a mask. You have to we had teachers who were trying to get around wearing a mask and say, what if I wear a face shield instead of a mask? You got it. We have to wear masks. If we have to wear masks, then definitely the students have to wear masks, right? I mean, I'm going to be talking the whole time, and I have to wear a mask. The students have to wear masks as well. It's the mandate. So just kind of be prepared. It's not a decision I can even make, right? So if you're an anti-masker or an anti-vaxxer or something like that, the classroom is not going to be the place to share your opinion about it and try to talk me out of it and let you be in the classroom. It's not a power I have. If you want to express anti-mask views or anti-vax views, go to the board meeting. Tell the board how you feel about it. They're the ones who vote on this kind of stuff. So that's the appropriate place to do it, right? We're not going to have, it's not the appropriate place to do that in the classroom, all right? And that's how it is. That's how you're going to get in, is you have to jump through these hoops, and then hopefully at some point in the future, probably not this semester, but down the road, months or years from now, hopefully we'll have a more comfortable, easier situation getting into the classroom, but that's not now, right? That's far away. So just be prepared for that. It's all going to be enough of an adjustment for us getting back in the classroom. We don't need extra friction about other stuff, okay? So be prepared for that. That's coming up. Oh, and then speaking of the calendar, so we've got some stuff to talk about. So we are, we're here on the 8th, right? Yeah, we're the 8th right here. So the first time we'll be meeting in class is this 15th date right there. And then your first exam is going to be the 22nd. Okay. The 22nd will be your first exam. So the way this is going to work is we will continue with a bunch of the material today. We'll get through like most of the rest of the material that we need to get through today. And I probably will just assign, remember, we being a hybrid class, I cover the important stuff in class that I think is the most pivotal information that you need. And then the stuff that I think is kind of just like, they can get this from watching a video, then we put that in a video. So this will most likely, depending on how time goes, this will most likely be the last time that we meet to talk specifically about Chapter 2. Continuity is only going to take us a few minutes to say the things I need to say. The derivative is pretty big and important, but the things I need to say, I think we can get through, and then you'll be working on the rest of it using, the videos online and the homework and that kind of stuff. Differentials, basically I'm going to do one example of differentials, and then, or I might even just assign it out of the book. There's not even a homework assignment on it, but I have to go over it. But we almost never use it in the entire class. Like, we don't come back to differentials again. So it's not really a big topic. I won't test you on differentials. Okay, so 2.6 is very minimal. Just watch the videos though, okay? Watch the video on differentials so you understand what a differential is. You might take a calculus class later where someone expects they use the word differential and you're like, wait, what was that thing again? So you kind of need to know that, but we barely use it. So, and continuity, like I say, is actually a very short section. 2.4 and 2.5 are huge, and then 2.7 is just an applied section. So it's applying the derivative. Like, if you understand the derivative from sections 2.4 and 2.5, 2.7's like, there's almost nothing really to talk about. It's just because the marginal cost, marginal revenue is just the derivative. So if you understand the derivative, then you get trained. Whenever you see the word marginal, derivative, you think derivative. I mean, there's a couple problems we'll look at, but that section's pretty straightforward. So then what's going to happen is, and that, don't take offense if you have trouble with that section, but come get help. Come to office hours, go to the tutoring center, get that help along the way. But it's one of those things where once you see how to do it, you're kind of like, oh, okay, I get it. That's not that complicated. But, it might be confusing at first. Now, the derivative itself is confusing at first. That takes definitely some time to get used to. But the other parts that we're looking at now with the derivative are not bad. So what we'll be doing today, February 8th, is we're pretty much wrapping up the chapter, the parts that we're going to be covering in class. When we meet next time in class, I might have like 15, 20 minutes that we're going to go over, depending on where we end today. I might spend 15 minutes talking about marginal costs and do one or two problems. But what we're going to mainly do on the 15th is get ready for that test. Okay, because your test is the 22nd. The 15th, we're getting ready for the exam. Okay, so that's someone was just slightly ahead of me where I was going with the discussion. So basically what we're going to do on the 15th is I give you a practice test. If you want to call the practice test a study guide, that's fine. Call it whatever you want. The practice test / study guide is to give you an idea of what the actual test is going to be like. Now, here's what I want to make this clear. I reserve the right to take the study guide or the practice test and change problems to something different on the actual test. Okay. Some students think that like I'm not allowed to change problems. Like all you're allowed to do is change numbers. I can change whatever I want, right? I'm the one who writes all this stuff. So don't look at the practice test and go, well, he didn't ask this question, so I don't have to learn how to do that. I'm telling you, I'm not going to cover differentials, but anything else really is fair game. Now, with that said, I'm not trying to trick any of you. I'm not trying to confuse any of you. I'm not trying to be real clever on a test or like, some teachers take a lot of, I've worked with a few teachers over the years that take a lot of pride in students failing their exams. They're like, oh, my tests are so hard. They're known for being so hard. I don't get it. I don't know why you would do that. What's the point of that? The exam is just for me to figure out if you learn to do the important problems in the class. That's what I want to know. Do you know how to find a tangent line? Do you know how to take the derivative? Do you know how to calculate a limit? Do you understand the concept of a limit? Do you understand those things? Great. Let's move on to chapter 3. Okay. My concern is not like weeding people out and like, oh, you weren't clever enough. You can't figure this out. So I'm not trying to trick anybody, but I do reserve the right to change problems on the test and modify them in whatever way I want. But what I will say is the practice test will largely be similar, not identical, but similar to the actual test you're going to take. Now, similar in what ways? Well, I can make changes, but it's not like going to be a completely different test, right? You're not going to take the practice test and go, okay, I kind of understand the practice test, and then sit down for the test and you're like, where did these problems come from? I've never seen any of these before. The things that I put on practice tests, the things that I put on tests, will look similar to homework problems we've done, I can't say that you've done the homework problems. It will be similar to homework problems I've assigned. It will be similar to problems that I've done in class. So anything that I've done in class, anything that was on the homework or similar to those problems is fair game. I'm not going to just pull something out of the blue and be like, oh, well, we never did a problem anything like this, but if you put these pieces together, then you should have been able to figure it out. That's kind of hard for people to do on a test, right? But, if you have done the homework, if you have attended class, you should be able to do most of the problems that are on the test. The problem comes in when people start trying to guess what I'm going to put on the test, and I'm only going to study this problem because it was on the practice test, but then I change it to a similar problem from that section, and then you're like, well, that's not fair. You changed the problem. Right. I'm not giving you a practice test to tell you only study these problems. The practice test is to give you feedback about how well you understand stuff. There's a, I forget what it's called, but there's a principle in that they've sort of figured out in general, like cultural, but it applies to education, where people are not good at estimating their own ability in a classroom, right? And it's interesting. What they've shown is the students who score the highest, so we're talking like the A's and the high B's, those students underestimate their ability. They think they do much worse than they actually are. So the students who get A's are kind of anticipating they're not going to do great on the test, and then they get like an A. It's inverse the other way around. The students in the bottom part of the class tend to overestimate their ability. Students a lot of times are shocked, like, how did I get an F? I thought I had all this stuff down and it was super easy, right? So unfortunately, people are not good at judging their own ability in a classroom. In fact, one of the things that you can do for yourself as a student is to build that as a study skill. Find ways of testing yourself about how good you are at a specific topic, right? I have students all the time that are like, well, I understood all the material when you did it. It's easy when you do it on the board. Well, yeah, everything's easy when you watch someone else do it, right? Building a house is easy when I watch someone else build the house. Well, yeah, because I'm not doing anything. I'm just sitting there watching someone else do it. Like, it's hard to think of anything that isn't easy when someone else is doing it, right? So what you need to do is test yourself when you're doing it. And that's the point of the practice test, is you're doing the problems, right? And I encourage study groups. Those are great. But at some point, you have to work on the stuff by yourself. Can I calculate a tangent line by myself? Can I calculate a derivative by myself? Can I actually do all these things? And that takes practice. And that's the point where sometimes people are like, well, I got together with my study group and we did all the problems. Well, that's great that we did all the problems, but on the test, you have to do the problems. And sometimes it's easy to underestimate how much help you had from that group, nudging you along the way, giving you hints, helping you out, answering questions. Whereas if you had just been by yourself, you might not have got far into that problem at all. So the study guide or the practice test gives you a chance. Basically, this is how it works. We come into class. The first portion of class I give you, it varies on the class. Maybe 40 minutes, you all work on it by yourself. It's just like a test. If someone came into the classroom, they'd think you're all taking a test. You're not talking to each other. You're writing with a paper and pencil. You're not looking in your book. You're not looking in your notes. It's a practice test. You are practicing taking the test. And then what you do is, what we do is after 40 minutes, or roughly when I think the class is ready, I'm watching, and if I see that everyone's stumped and like they're pretty much done, I'm not going to make you wait another 10 minutes. So I kind of try to gauge, okay, I think we're about at that point. Then I open it up, and you all start working together. At that point, you can check your book, you can check your notes, you can talk to each other, you can help each other out. Right? And we're going to have to be a little careful because we're going to still want a social distance, but we'll as a class kind of decide how that works. I'm not going to force you to sit, 6 inches from somebody if it makes you uncomfortable. We're going to make sure everyone's comfortable with what they're doing, but it's helpful to be able to ask people questions. And then you're going to work together to get the answers for the study guide. Okay? So you're going to help each other through it. So at that point, you're using the book, notes, all those resources in order to get the answers to the study guide completed. So I was just going to say something and then I forgot. Oh, the thing you should do, and I'll remind you of this, but when we transition from the part where you're working by yourself to the part where you're working together, before you do that, go through and put little markings on each problem, right? And you can use whatever way of noting that you like. But the ones that you like aced them and you're like, I know this one inside and out, put a little note there that's like easy or E for easy or something so that later when you look, you go, that's right, I totally knew how to do this one. And then mark the ones where you had a little bit of trouble with, where you're like, I mostly got through this problem, but I did have to get a little bit of help to finish it. That means you probably want to spend at least a little bit more time studying those problems. And then the ones where you're just like, I have no idea. I have no idea what this problem is about. Mark those with maybe an H that says hard or something like that. So you can, so then those are the ones I need to study a bunch more. So that means in the week between the 15th and the 22nd, you have this study guide that you worked through, and you also have notations about which problems you need to spend more time studying. So that you can do that. You can go back and go, okay, I need to spend a little bit more time on problem 4, and I need to spend a lot of time on problem 5. Maybe I need to go to the tutor center and get help on problem number 5, right? You have a week to get that done before you come to class and take the actual exam. Okay, so that's kind of how that's gonna run. And there's more to talk about, but let me check the chat really quick. We got. Yeah, so there's a comment in here, if you mentally tell yourself you're terrible, that typically becomes an outcome. Yeah, and I see it. I see students who are good at math, but they have a level of anxiety that comes up associated to tests, a lot of times because either some teacher at some point along the way made you feel terrible, a parent maybe made you feel terrible about math, and so people have all this anxiety and emotions come up, and even a student who is good at stuff, if you're having an anxiety attack during a test, it's hard to do well on the test. Your brain switches modes. Like, you want to be relaxed. A lot of teachers do breathing exercises at the beginning of a test because your brain works the best when you're relaxed. If you're scared or anxious, your brain goes into fight or flight mode. Fight or flight mode is not where we carry out complex calculations, right? It's where you either fight or flight. That's what your brain is working on. Do we fight someone or do we run? That's the mode your brain is in. You want to come down calm. Go, I prepared for this. I'm ready to go. I did the homework. I can do all this stuff. And then, hopefully be fine. There's a question, will we be able to work in close proximity if we all say it's okay? Yeah, so no one's going to be forced to sit right next to somebody else, but if you're comfortable being in the, couple feet from somebody or something, you'll be able to do that. You'll be able to come together. I don't want anyone to think that I'm forcing you to sit right next to someone. I'm not real comfortable being too close to people right now, so I'm not gonna force that on other people as well, right? My son has some immunity issues, so I got to be real careful I don't bring it home into my house. So and other people have other situations where they have maybe their grandparents live with them at home, certain stuff where it's really important you not bring it home to your family. I'm understanding of that. So you'll see I kind of try to keep my distance a little bit when we're in the classroom for now. I'm not going to be like hovering right next to you. And I respect if you want to keep some distance as well. But if you're comfortable sitting right next to people, that's going to be a little bit of a choice that you can make. There will not be additional assignments for, will we have additional assignments for the next chapter during the week that we'll be able to study to study the practice test? There won't be any additional assignments specifically for than the homework that's given. That's usually already quite a bit for students to work on. And then what generally happens because there's two major points I want to make sure everyone understands so that they're going into, and one was already asked about getting the answers to the study test. So I've been doing this as test prep for, 12 years now, and I've pretty much learned what works and what doesn't work. And so what I have found, the best method I've run across is you're going to have 40 minutes to work on the problems. You do your best, maybe 35 minutes. We'll see I'll watch the clock, make a decision. Then you're going to work together. After another 15, 20 minutes, I'm going to come around to basically whatever groups you've all formed. And sometimes if people are working on by themselves, I might take 3 or 4 of you and say, you're in a group together. Doesn't mean you have to sit right next hip to hip with that person, but you'll be in a group with those people. And then I assign those groups problems from the study guide, and you put them on the board. So it's really a collaborative process. Everyone in the class is interested in figuring out the answers, so you all need to work together as a group, right? The whole class. So in other words, you're an individual, but you will be in a small group working together. But then also the groups can interact. There's nothing to say that one group can't go talk to another one. If your group was assigned to put problem 5 on the board and you're stumped, but you know that group across the room knows how to do problem number 5, go talk to them. They're going to be glad to tell you because you're all in the same boat, which is you all want the answers to these questions, right? So go over there. And it's not just the answers. You want to show how you did the problem. So what happens when we leave is if everything goes well, if you all work together well, all of the problems will be worked out on the whiteboard in the classroom. And what generally happens is, students are trying to write it down and take notes, but you will see people on the way out of the classroom taking photos of the whiteboard so they can go back and study that work later. Okay, so 2 things that students don't always like, but I have major problems when I don't do it this way. 1, I will not send you or post the practice test. Okay, I used to do that, but what happens when I post the practice test, or if I don't and I email it out to students, what will happen is on Tuesday, 50% of the class will email me and tell me how they're sick, but they'd like me to just send them the practice test. So what happens is we don't have anyone in class, and then this whole study concept falls apart. Okay, and then the other thing is students go, well, why can't you just send me the practice test and then I can work on it at home? Those same students who I send the practice test to, they end up failing the test because they didn't really work through the study guide and they didn't have that in-class participation working through the study guide. So it actually lowers scores when I do that. So because of that, I do not email out the study guide. If you want the study guide, come to class and participate. Okay, be part of the study group if you want the study guide. Okay, so there's that. I don't send it out. I used to do that, but like I say, it caused all sorts of problems. The other thing is I do not put the answers on the board. You put the answers on the board. The other problem, the reason this comes about is because if students know I'm eventually going to put all the answers on the board, a third of the class just kind of sits there and looks at me for 30 minutes. And they don't really work on the problems. They just wait for me to put the problems on the board. That's not really helpful, right? You're not really learning it if you're not working on it. You're not working on it if you think I'm just going to do it all. So usually if students are working together, they're able to get all the problems solved and up on the board. Okay. The problem is when it takes a while for people to kind of warm up and they're kind of hesitant and afraid of each other. And then, then they're scrambling at the end to get stuff on the board. And then sometimes one or two problems doesn't end up on the board. So you just want to go in with the right mindset of like, we're all in the same boat. We just want all the problems on the board by the time we leave. Let's work together as a class. Let's get it done. Okay. So you think of yourself as, some sort of collective where you're all working towards a common goal here, which is to get the solutions up there. Because, what I find is if I email out this practice test, people don't show up to class. If I do the problems, people don't do the work in class. So it is very possible. Most of the time, 85% of the time, students get all the problems on the board, but you have to be ready to work at it and go through it. Also, what I would recommend is doing some studying before you show up. If you show up cold, like this is true for any type of study session. If you just show up cold and you haven't done your groundwork yet, then you're not going to benefit from it. It doesn't really do you any good. It's just you're watching someone else do another problem. Well, you've already seen that, so it's not really helpful. But if you've worked on a topic and you're like, I can do like 80% of this problem, but I really have trouble with the last 20%, and you're working on it, and then you come to class and do it the next day, that's when you go, oh, that's how you do the problem. I get it. Now I see how to do it, and then you know how to do that problem. But if you wait until, like, if you just come in and then you do the practice test, and then you're like, I don't know, I'm just kind of confused, you're going to have trouble getting that remaining 20%. It's almost like it's doing the prep work, preparing properly for the study guide. So that's what I would recommend. And I can see it in students. I can see, like, when I'm watching people do it, like, this person was prepared to take the practice test. This person didn't look at calc for a week, and they kind of came in and thought this was going to be helpful. And you can see the one person benefits greatly from it. The other person does not. So that's my recommendation. Kind of coming in having already studied for the exam, know how to do derivatives, know how to do limits, that kind of stuff. Then you probably be largely ready to take the practice test and do that second layer of studying. It's kind of like layer 2. Layer 1 you should kind of do on your own. Same thing if you get together with a study group. You should look at stuff first, then go to the study group. Same thing here. Look at your stuff first, then come to the practice test. Then what will happen is hopefully you leave with all the solutions, or at least most of the solutions, and the work to do the practice test. Then you have another week to learn all those problems really well and improve your understanding for the next week, so that even if I do change a problem to a different, maybe like when we do logarithms, derivative of logarithms, maybe there was one type of logarithm derivative on the test, on the practice test, and then on the test I change it to a different logarithm derivative problem. Sometimes people get upset and they're like, you didn't put the same exact problem on the test. Right, I'm telling you right now, I'm not going to put the same exact problem on the test. At the very least, numbers will be changed, and possibly the problem will be changed to something similar but different. So just be aware of that, right? I think we covered everything I needed to talk to about that then. So that's where are we? Oh, yeah. So the 8th is today. The 15th, we will be practicing stuff. The 22nd is your test. And you'll definitely want to be there for that. Okay. With that said, this chapter is a little bit unique this test, because chapter 1 was all review. So theoretically, you learned it all before you got here. Okay. So when I create the test, I will not be creating, or I will not be pulling problems specifically from chapter 1. Okay. The problems on this test will come from chapter 2. Now, most people kind of understand that means you still need to know how to do chapter 1, because we didn't make you do all that review in chapter 1 just because I want to see you do a bunch of problems. It's because many of these problems you can't do if you don't know how to factor. Many of these problems you can't do if you don't know how to solve an equation, a quadratic equation especially. I see lots of students that, they get stumped when they can't solve a quadratic equation by factoring, and it's not factorable. What am I supposed to do? Well, you had 2 algebra classes that taught you how to use the quadratic formula. Use the quadratic formula. So all that stuff you need to be comfortable with. The basics we learned in chapter 1 about cost, revenue, profit, all of those, kind of at this point, you're expected to understand those basic understandings of cost, revenue, how to construct those functions, that kind of stuff. If not, you're just going to be lost in this class. A couple questions popping up here. Let's see. You can use a basic calculator. You can use a graphing calculator, TI-84, if you want for the test. It will be paper and pencil, so I'll hand you a packet that's, 2-3 pages. It'll have problems on it. You'll write it down on a piece of paper, all that kind of stuff. So it's traditional style test that you'll be taking, paper and pencil. The retakes, so for those of you who do poorly, there will be a retake opportunity on this exam. I'll go into detail about that when you get your tests back, because right now you don't really know if you need to take the retake or not. When I'm giving you your test back, which I'll give you the next time I see you, you'll take it one time we meet. The next time we meet, I'll give you your test back, and then I'll tell you all about retakes at that point, because then you'll know whether you need to take the retake or not. If you get an A, you're like, oh, good, I don't have to worry about the retake. If you get a D, then you're like, ooh, I better get this grade up. Okay, so I'll give you all the information about the retake, but it will be, we'll talk about it next time. So, at that point. So, limits are going to play a large role on this test, and so are derivatives. Those are kind of the big ones. Marginal analysis involves that. There'll be some, I will have a problem from every section on here in the test, except for differentials. I'm not going to put a differentials problem on the test, but the rest of these, you can expect at least one problem from each of these other sections here. Probably not a ton of questions on continuity, probably just a couple questions on marginal analysis. You can expect to see a lot of questions from this. Oh, it looks like I have a typo. Let me fix that. You can see, you can expect to see a bunch of limit problems. I'm going to give you graphs and say figure out the limit of this graph. I'm going to give you functions with no graph, say figure out the limit. Right, all those kind of problems you've been doing on the homework, you're going to do them on the test. And there's a bunch of them, because most limit problems, if you know what you're doing, just take a few seconds. If I give you a graph, find these 4 limits from this graph. If you know what you're doing, that might take you 30 seconds to do all 4 of them, right? Or however many I have. 1 or 2 problems on continuity. You're going to have to do some problems on the derivative and then basic differentiation properties. Okay, so we'll dive into the derivative in just a second, and then there'll be at least a couple marginal analysis questions. Okay, but like I say, 2.7 is pretty straightforward. If you know how to do 2.4 and 2.5, 2.7 is not really going to stress you out. Okay, with that said, let's get into the derivative then. Oh, there's a question about a note card. No note card. This is one of those classes where you don't have to memorize a million formulas. If it's something weird like the Gini index or something like that, I'll probably give you the formula on the test. But by and large, your derivative formulas and all that kind of stuff, you need to know those. Like, you just have to know how they work, or you're not really doing calculus. So, like, if you don't know how to take the derivative of a polynomial, then you haven't done enough homework problems. If you don't know, you need to keep working on those. If you don't know how to do the product rule or those, do more homework problems. And the process of doing that will help you remember. Okay. So no note card. Are there going to be review questions from chapter 1 on the test? Oh, right. So a couple questions. So I just mentioned that. I'm not specifically pulling problems from chapter 1, but there will be the problems that I pull from chapter 2 sometimes will require you to understand chapter 1. right? You're going to have to factor. You're going to have to use the quadratic formula. You're going to have to solve equations. So all that algebra from chapter 1, I'm not going to ask you specifically like figure out the double time for this compound interest problem like we did in algebra. I'm not going to ask you specifically that problem, but you may have to do that in the course of one of the chapter 2 problems. You see what I'm saying? So all the problems that you're going to see on the test will look like they came from chapter 2, but you need the algebra from chapter 1 to do them. Okay, so we better get into some of this as we go. So again, remember, this is a hybrid class. I don't have time to cover every single thing in class. I'm giving you the information that I think is going to help you the most, and then you have to supplement it with the videos and getting help from office hours and the tutoring center and all that kind of stuff. Okay, with that said, let's jump into it. So continuity we'll go through pretty quick. As like I say, it's one of those things that scares people, and I think people overthink it and make it harder than it is. I think it's largely because you're still getting used to the notation. But continuity, you can think of continuity in a very loose sense, like a non-rigorous sense, as can you draw this without lifting your pen off the paper? If you have to pull your pen off the paper and put it down somewhere else, there's probably a discontinuity there. Okay, if you can draw a curve or a line without lifting your pencil, then it's continuous. But that's not a very mathematical way of thinking about things, right? That's a little bit of a sloppy way of thinking about it. And when you get into higher level functions that you'll get a deeper after calculus and into linear algebra and all that kind of stuff, you'll start finding functions where that intuitive understanding of continuity starts to fail you. We're not going to run into those too much in this class. So here's our definition for continuity. Why do we care about continuity? Continuity is great. Continuity makes your calculus so much easier. When you're dealing with discontinuities, places where your function is not continuous, it takes there's a lot more care and consideration that needs to go into performing the calculus. If you have something that's continuous, a lot of times you're going to be real happy about it. This is why we like polynomials. Polynomial functions are continuous. That makes the calculus on polynomials way easier. Okay, so it's important to us to understand when something is continuous and when it is not continuous. So we have this definition of continuity, which at first looks very complicated. It's not. Okay, so let me explain it. A function f is continuous at the point x equals c if the limit as x goes to c of f of x exists. So we're talking about continuous at a point. We sometimes talk about the continuity of a function. Like I just said, polynomials are continuous. What that means is the function is continuous at every single point. So continuity is really a characteristic of a point on the graph, not the whole graph itself. But if every point is continuous, then we just say, yeah, the function's continuous. Okay, so you want to think about a specific point on the graph. Are we continuous there, or is there some kind of a jump continuity? So you've been hopefully doing your homework on limits. So does the limit exist? Does the function itself exist? And does the limit equal that function value? So this seems weird at first, I know, because you're still getting used to limits and people are confused on limits, but we can kind of make sense of this. Here is a place where we have a hole poked in our graph, right? So let's consider at 3, x equals 3. Is this function continuous at x equals 3? Well, could I draw this without lifting my pen off the paper? No, because there's a jump right here. It's getting really, really close to this point, then it jumps down to this point, then it jumps back up. You can't draw that without lifting your pen off the paper. So we intuitively know it's discontinuous, but how do I apply that definition to know this is discontinuous? Well, we break this number 3 right here. The limit of f of x at x equals c is equal to f of c? No, because if we look right here, hopefully you're recognizing at this point the limit is 3. The y values are approaching 3 from either side, but the function value itself is 1. So the limit is not equal to the function value. Think of the function value as where the function is, and the limit is where the function is going. If where the function is going is not the same place that the function is, then they don't meet each other, right? It's like if I'm going to meet up with you for a meeting and you're in Camarillo, but I'm going to Oxnard, then we're not going to meet up, are we? We're going to be in different places, right? But if you're in Camarillo and I'm going to Camarillo, then we can meet up. Well, that's what the function is doing. Is the place where the function is going, the limit, the same as where the function is, the function value? If so, then yeah, you have continuity, right? Think about this point right here where there's no break. Well, right here at x equals 2, well, the limit would be 2, and also the function value is 2. So yeah, the function is going where the function is. Yeah, it's continuous right there. But you could see we get these other breaks. This over here is what we call a jump discontinuity. That's where there's actually a break between the function, right? It's not smooth like where it connects up nicely. There's a break. So there's different types of discontinuities you can have, but if you're ever, and sometimes it's obvious when you, especially if you have the graph, but sometimes when you're dealing with the algebra of the function, it's a little bit harder to tell when something is continuous or not continuous, right? So then you have to fall back on the definitions, okay? And there's some good examples in the book, and they go through, you calculate the limit, you calculate the function value. Are they the same? Then you're continuous. Are they different? Then you're not continuous, right? That's pretty much what it comes down to. But you want to be able to recognize it because, like I say, our lives are made significantly easier in calculus when we know something is continuous. Things become much easier. Okay, let's jump to the derivative. And you can see right out of the gate, they're showing us a tangent line. Oops. I keep having to move this because this book reader is really strange, and it's hard to get the sizing right and still have it big enough that I can show you stuff. So you have to forgive me moving it around. Tried to streamline this, and it doesn't always work great. So here we see a curve, and we see this thing called a tangent line. What does that mean? Well, the tangent line is an extremely important idea. And for the most part, it comes down to finding the equation of a line. Remember, you were finding equations of lines in beginning algebra. Well, you'll be surprised how much time you spend find equations of lines in calculus, right? It's not sometimes people go like, but I learned that 2 years ago. Why are we doing it again? We're doing it again because it's part of calculus, okay? So a tangent line is one that does this. It comes in carefully, just touches the line at one point, and then continues on, okay? Now notice, like if we continued this tangent line, notice how it would cross the curve down here. And people go, well, it's not touching the line more than once. It's touching it down here too. But remember, we're just concerned about this area right here. So right here, is it touching the graph more than once? No? Then okay. Then it could be a tangent line. That doesn't guarantee it's a tangent line. But in this case, if it's, see how it's kind of acting like the curve? This line is kind of at the same angle as the curve. That's the point of the tangent line. The tangent line is used to approximate the curve at a specific point. That's what we do in calculus. We say curves are confusing to analyze at a high level. Why don't we treat it like a line, and then we can analyze that line because we've been dealing with lines since beginning algebra. So that is a thing you're going to be calculating in the homework. Find the equation of the tangent line at this point given this function. That is a very common question. I can basically guarantee you are going to have a problem on the test that says find the equation of the tangent line at this point for this function. Like there's like 3 or 4 problems. I'll tell you straight up it's going to be on the test. So know how to do them. I'm always surprised when I tell a class, hey, this problem is going to be on the test, and then like 20% of the class misses it. It's like I told you it was going to be on the test, right? So be prepared for that. You'll do a bunch of those on the homework. So you should be able to know how to do it, but make sure you're paying attention to it. All right, rate of change, right? You remember that? What was rate of change? When have we heard rate of change before? That's the slope of a line from algebra. We oftentimes talked about the slope of the line being the rate of change. So we have this really fancy looking rate of change here. This formula looks confusing, but if we look, this is actually the difference quotient. Right? Remember, I think we talked briefly last time about how the difference quotient is really just the slope. That's what it is. So let me show you more in depth here. There should be a picture. Where'd the picture go? Did they take it out in this edition? There's usually a picture here. No, they must have removed that one. That's one thing about this book. I feel like they take kind of a while getting to the definition of the derivative, and it's takes a little while to get there. I feel like they could be a little more direct with it. So let's jump to the definition of the derivative, and then we're going to come back. You'll see this thing keep popping up. The limit is h goes to 0 of f of a plus h minus f of a over h. They define it like 4 different times and give it different names. And it's kind of like, why don't we just get to the derivative? Okay, so the derivative. So given a function f of x, we define the derivative of f at x, and we denote that with a little dash by the f, the little like apostrophe. That means derivative. So it means we took the function f and we took its derivative. So see how f of x is just f and then f of x like we're used to? F with an apostrophe of x, that means the derivative of the function f. And the letters always match up. So f apostrophe is the derivative of f. G apostrophe would be the derivative of g. Okay? So we write that the derivative of f is the limit as h goes to 0 of f of x plus h minus f of x over h if the limit exists. Okay? Now that looks like a lot, right? We're using the limit, and you're still getting used to your limits, and that's okay. But this is the limit of the difference quotient. The difference quotient that you learned in college algebra, and we made you do, and then there was a couple times it came up. I think last week we looked at it real briefly. The limit of the difference quotient is what we call the derivative. Now, what are we really getting at? Why would I look at the derivative of the difference quotient? And then also you said that the difference quotient was really just the slope. Why am I looking at the limit of slopes of a function? Why would I even do that? Well, let's take a look. So there's this thing called, oh, this is frustrating. I have to have this centered here. Let's see. I'm going to move this over now. Okay. So I've got this in Desmos, and you don't even need to see that part, I guess. You just need to see this part. So, okay. So, see this right here? See how this line is crossing our graph at 2 points over the area we care about? That's what's called a secant line. So, a tangent line touches the graph once, and it also has to be, it can't just cross, cut right across the graph. It has to be just acting like the graph and just touching it in one place. That's a tangent line. This is a secant line. That is, it's touching the graph in 2 places at once. Well, secant lines we can just easily calculate using the slope formula. But notice what happens. See, I can have all these different secant lines right here. But if we're concerned about the derivative down here at x equals 1, that's where we want to know about our derivative. Well, if I create the secant line, then look what's happening as the 2 points that I use to calculate the secant line. Remember that we did this in algebra all the time. Find the equation of the line that passes through these 2 points, right? We could do that for all these different versions of that black line I'm showing you. We could calculate the equation of the line using the 2 points that lie on the line. Well, notice what happens as I bring these points together. Okay, as I'm bringing these points together, all of a sudden that secant line becomes this green line down here, and you go, wait a minute, what just happened? Now it's the green line. That green line is the tangent line, right? Because we can see the green line is it's going through the point we care about, and it's only touching the graph at 1 point, and it's acting like the graph. So when I say that, in other words, if we had y equals 2x minus 1. See, like this red line here, let's make it a different color. Let's make it black for the moment. Okay, this black line, well, it's only touching our function once right here. We could make it so that it goes, it could only connect far. We could make it so the second point it connects to is far away. But this, you could say, well, right around 1, it's only crossing the graph in one place, but it doesn't really act like the graph. It's like slicing through it. Whereas this green line, we could say, acts like the red curve at this point, but the black line doesn't. So it's that you only touch the graph at one point, but also your line is acting like the graph. It's just coming up and touching it, not cutting through it like this black one, okay? So as the distance between the points decreases that we use for calculating the secant line, as the distance between these points decreases, our secant line becomes the tangent line. Okay, so think about that in terms of the definition. Okay, now I'm going to have to switch back and pull this up. So in terms of our definition, the limit as h goes to 0, h is the distance between the x values on your point. So as I'm bringing these together, that's shrinking h towards 0, because h, like right here, we have an x value of 1, and for this point an x value of 3. That means h is 2. It's the difference between your x values. As I shrink h towards 0, our secant line approaches the tangent line. So, okay, so keep that in mind. Let's look at the definition again. It's the limit as h goes to 0. In other words, we're bringing those points together, of the slope of the secant line. That's, remember, the difference quotient is just a slope calculation. It's literally the slope formula written in a slightly different form. So what we're saying is, what is the limit of these secant lines as we get the 2 points closer and closer together? Well, in the limit, you get the tangent line. So that's why that tangent line is really important, because look what happens when I zoom in on this tangent line. Like if we zoom in here, we can see it's almost indistinguishable as we get super, super close, right? If you're looking right around the point, it's really hard to tell the difference between the line and the curve. That's what a tangent line is all about, is that the line is a really, really good approximation for the curve right at that one point. Okay. Now, as we zoom out, of course, we could say, well, right here, the line is not a good approximation for the curve. Look at the distance between these. Right. We would have to calculate a different tangent line at x equals 2. So each point has its own tangent line. But once we calculate that tangent line, it's helpful. Okay. So you go, okay, well, what's the derivative really doing then? Well, the way you want to think about this is giving us, remember that the slope was a rate of change, but we always found the slope between 2 points. What we're effectively doing here with the derivative is finding the slope at a single point. What is the slope of my curve at this one point? So we go, okay, wait a minute. So I'm finding the slope at a single point, and slope was the rate of change. So this is giving me the rate of change at a single point. If you calculate the slope over 2 points, the rate of change, then you're getting the change over that interval. Calculus allows us to find the slope at a single point. We call that the instantaneous rate of change. Okay? So that's where a lot of this other definition that the build-up in this section starts to make sense. Think of it this way. In algebra class, I could come to you and say, okay, well, in order to get here today, I drove on the 101 for 1 hour, and I went 75 miles. And you could then say, okay, well, I'll take those 2 points. At time 0, you started at distance 0, and at time 1 hour, you were 75 miles apart. So that means that I can calculate your rate of change using slope was 75 miles per hour, right? And that's great. You just calculated my average speed. Okay, that's useful. But if I ask you what my speed was at any given time, you can't answer that. If I say, well, what was my speed 15 minutes into my drive? I don't know, right? Maybe I was over by the 405 and like everything slowed down. So I was like barely moving in traffic. And then, you know, when we got closer to Oxnard, then I was like flying. Maybe I was running late, so I'm going 85. So using algebra, you can calculate the average rate of change over a period of time. but we can't say anything about it at a specific time. Well, calculus allows us to do that. If we have the curve, we can calculate the derivative at any given point, and that gives me the instantaneous rate of change at that moment. So that's where these other definitions start to come in. Instantaneous rate of change. You go, wait, isn't that just the definition for the derivative? Yeah, the derivative gives us our instantaneous rate of change. That's right. And this can be helpful. Like one thing that's a really good example to think about, and I think really whenever you get confused, go back to this example. We use it a lot because it's usually the clearest way that people can think about stuff. So the derivative is giving us an instantaneous rate of change, right? Okay, so think about position. If we had the position of a car at every instant over an hour, and we took the derivative of that. So the derivative is telling us the rate of change. What is the rate of change of position? Imagine you're in a car. What word do we use for the instantaneous rate of change of position? We call that velocity, right? Think about it. When you're driving, the velocity, the speed at which you're driving, speed and velocity are technically not the same thing if you're in a physics class, but for here, you know, we're not worried about vectors, so we can say speed and velocity are the same loosely. Don't say that to your science teachers. But for this class, that's fine. If you think about it, what is speed measuring? When you look down at your speedometer and it's telling you you're going a certain speed, what is it really telling you? It's telling you how fast your position is changing. If you're going 25 miles per hour through a residential neighborhood, your position is changing relatively slowly. If you're out in the middle of the Utah desert on Highway 70 and there's no one around for 100 miles, your rate of change is probably pretty fast. You're probably driving pretty fast out there, right? Your speed is higher. Your change of position is higher. So you want to think about this hierarchy because it's going to help you through a lot of problems. You start with position. You take the derivative of that. That gives you velocity. And you go, okay, I see how velocity is a rate of change of position. Okay. What if we take the derivative of velocity? What is that? Do we have a term for that? What does that tell us? Well, what would the change of velocity be? When you get in a car, from the time you turn the car on till the time you turn it off, are you going the same speed? No, because you generally start not moving, right? So you go from not moving to moving at different speeds and stopping and starting, and then you stop again. So your rate of change of position, the velocity, that changes a lot. So what do we call the rate of change of velocity? Well, that's acceleration, right? When you push the pedal down further, you're speeding up, your velocity is changing. And velocity is the rate of change of position. So now it starts to, it's almost like Inception. We've got like ideas inside of ideas. We have a rate of change of a rate of change. Starts to get confusing, but just spend a little time with this example and it'll help you understand a lot of the other ones. If we have position, the rate of change of your position, the derivative is the velocity. If you have velocity and you want to know the rate of change of velocity, that's your acceleration. And in physics classes, you even go one further. You can talk about the rate of change of acceleration. That's called the jerk. We won't use that in this class, but if any of you have taken physics at some point, you probably looked at those. Okay, so yes, this is the definition for our derivative. It's also the instantaneous rate of change because those are the same thing. Okay, that's powerful. We used to be able to calculate speeds over a given interval. We now can calculate instantaneous rate of speeds, right? Rates of change. That's helpful. Again, we have a picture of a secant line crossing 2 points versus the tangent line crossing, excuse me, getting the hiccups here. See the difference between these two lines? Which would you say, at the point P, which of these lines is a better approximation for the circle? Is it the green line or the red line? The red line is clearly a better approximation for that circle, right? Just at this point P, not out here at the other points, but right at this point P. If we could zoom in, I mean, it's a picture in a book, so I can't zoom in much. But if we could zoom in like I did on Desmos, that red line and that blue circle are going to look they're going to be very hard to tell apart right around P. But everywhere else, easy to tell apart, right? So that's that idea. That tangent line, the slope of the tangent line is the derivative. Remember we always talked about slopes being rates of change? The slope of the tangent line that you calculate is the derivative. In fact, that's how you're going to find the slope of the tangent line, is by taking the derivative, okay? And I know this is a lot to take in. It's going to take you probably the rest of the week for all this stuff to sink in and start to make sense. But, so I'm trying to go through the important information while I can. So, but feel free to ask a question if you have one. But I know I'm throwing stuff at you. If you leave today's class confused, that's actually probably a good sign, because you're not going to be able to take in 100% of what I say and understand it, but it will hopefully make sense to you later when you're working on this more. You're going to go, that's what he meant when he said that thing. Or, oh, I get the position, velocity, acceleration now. Cut yourself a break if you don't understand everything today. Just try to understand it over the next week before I see you again. Slope of the tangent line. Again, slope of the tangent line. Does that look familiar? Limit of the difference quotient. Yeah, we just saw it defined as the derivative, and we saw it defined as the instantaneous rate of change. They're all the same thing, but they are different ways of viewing that thing, which can be helpful, right? In math, sometimes one way of viewing a problem is way easier than another way of viewing a problem. So understanding all of these ways is helpful. So we've got the derivative. Yeah, then we have the derivative there. Yeah, and then here we go again. Interpretations of the derivative. Slope of the tangent line. Instantaneous rate of change. Velocity. The velocity is like an exact example. It's an example, but it's ways of interpreting it, right? If you think about that example of position, velocity, acceleration, and really spend some time with it, if you're sitting in a waiting room somewhere in the next few days, and rather than take out your phone and tap cabbages or whatever you do with your phone, just try to think about this example for a little bit and go, can I make sense of this? Because once that clicks, the position, velocity, acceleration, you'll understand like a large portion of what you need to know about derivatives. Okay, now you have to get to actually calculating derivatives. And calculating derivatives from the definition is annoying, right? I'm going to tell you straight up. Calculating them from the definition is annoying. This is problem number 2 that I'm giving you a heads up will be on the test. You will have to calculate one derivative on the test from the definition. That is using the limit of the difference quotient. We will be learning shortcuts for taking derivatives that you will be allowed to use almost all the time. One problem on this test, you have to use the definition. There'll be one problem on the final where you have to use the definition. So if you learn how to do it right, that's 2 problems right there. You're going to get done well. The rest of the derivatives we take in the class, we'll use the shortcuts. But I have to test you on one problem where you do it the long way, the annoying way, because it shows that you understand what the derivative actually is rather than just memorizing a bunch of shortcuts. So make sure that you can find the derivative using the definition. And I'll tell you right now, the one I have you do on the test will be a quadratic, so a second-degree polynomial. You will have to find the derivative of a second-degree polynomial using the limit of the difference quotient, okay? If I go higher degree than that, they get to be a pain. If I go lower degree, they're too trivially easy. That quadratic's right at the right point where it shows me you know what you're doing, but it's not super hard, okay? So I'll give you some quadratic equation. You find the limit of the difference quotient. So different students write this up different ways. These are going to be on the homework. Make sure you watch the videos about how to do this and that it makes sense to you. Basically what you're going to do, remember all that difference quotient stuff you didn't like doing in your college algebra or pre-calc or whatever you took to get here? Yeah, you're going to have to do that difference quotient stuff. And then you're going to take the limit as h goes to 0 of that problem. So make sure you, we're kind of a little short on time. Make sure you watch the videos. There's videos posted on the website, on Canvas, where you walk through this, where they walk through this stuff. There's tons of videos online about, if you just look up, derivative using the definition, or derivative using the limit of the difference quotient, or some kind of thing like that. You can watch people doing examples of it. It's a little tricky with the taking the limit of the and sending h to 0 can be a little tricky for people at first, but once you see how to do it, you're like, oh, that's actually pretty easy. I don't really like this example they do here. Basically what you're going to do, they break down the difference quotient into a bunch of different steps. Myself, I like to just jump to step 3 myself. So you take f of x plus h minus f of x, remembering that you have to subtract all of f of x. Put f of x in parentheses so you remember to subtract everything you distribute that negative in. Okay, otherwise people end up adding part of it and it doesn't come out right. But you remember your difference quotient stuff. So when they do the limit of the difference quotient, they get down to 4 minus 2x minus h. Okay. Well, when we send h to 0, this term here goes to 0, and you're left with 4 minus 2x. Okay? So you can see that's what happens here. When we take the limit of 4 minus 2x minus h, we send h to 0, you get 4 minus 2x. I know there's going to be at least one person on the test that uses the shortcuts on this problem and then says, well, I got the right derivative. I don't care about the right derivative. I'm seeing if you understand the definition of the derivative. So in order to get points on this problem, you have to do it the right way. You have to use that limit of the difference quotient, which I'm sure makes you a little nervous now because we haven't worked through a whole problem of it, but you'll have a week to work. Right now you have 2 weeks to work through these and get the hang of them. So for this one problem, you have to do it that way. But I'll say in the problem, using the definition of the derivative, and I'll probably even give you the limit of the difference quotient so that you understand, oh, this is the one where I have to do it this way. Sometimes students use it for every derivative on the test. You don't have to do that. You can use the shortcut for the other problems on the test. But for this problem, you have to do it the long way, and one problem on the final. Okay. So like I say, you'll see videos on explaining more in depth that concept, but make sure you know how to do that. And then there's finding tangent lines. You're going to do that. You 100% will have to find the equation of a tangent line on the test. Finding the derivatives for different functions, especially from the definition, the algebra gets bad quickly. It gets to the point where you're like, this sucks. I don't like doing these problems. And that's why we develop all these shortcuts in the next section. So again, use the shortcuts when you can, but on that one problem, make sure you're using the definition of the derivative. The square roots can be a little bit messy. Some of the algebra gets a little bit messier, but there are numerous examples in here about finding the derivative this way. So you can definitely look in here and go through these. Okay, so what does this have to do with business? Well, at business, we want to be able to analyze functions to a high degree. And you might want to know, well, what is our rate of profit at this point? Or what is our rate of revenue at this specific point? Because, if you're a business, you're looking to maximize profit. You're looking to maximize revenue, minimize cost. So you want to know, what is our cost at this one instant right now? Are our costs going up? Are they going down? These are all the kind of questions we're going to work towards answering later. And remember an increasing function has a positive slope. Decreasing function has a negative slope. Keep that in mind when you think about a derivative. You should be able to immediately recognize, oh, that's an increasing function because it has a positive rate of change. These are the kind of concepts we're going to be building on for the next couple of chapters, okay? Non-existence of the derivative. Sometimes a function is not differentiable. If you have a jump continuity, you can't differentiate at that point. You can differentiate at the other points that are continuous, but if you have a jump continuity, the derivative doesn't make sense there. Because what is your rate of change? Well, there's a weird jump. It stops making sense at some point. Right, so that's the official derivative. So make sure you know how to do those. Then what we get into is a bunch of shortcuts that we start to see patterns in what happens to our derivatives, and we start to find ways to shortcut things. These are helpful. We will use them for most of the problems in the course. Just remember, when I say use the definition of the derivative, you're using the limit of the difference quotient, not these. This rule right here, this power rule, this makes taking derivatives of polynomials real easy. If we have a function where it's just x to a power, like say x to the 5th, the derivative will be where you take the n. Is this big enough? Can people see this? Let me blow this up a little. Okay, if we have x to the n, like you have in a polynomial, in your polynomial you might have x to the 3rd, x to the 4th, x to the 2nd, right? What we do is we bring this exponent down in front, and then we decrease the exponent by 1. That's the shortcut. So for instance, if we wanted to take the derivative of let's say f of x equals 5x squared. So remember our notation. In my derivative, it's going to be what we call f prime. It's just what we call that apostrophe is prime. So f prime equals, okay, so what we just looked at, that power rule says I'm going to bring the exponent down in front, right? Remember right here, the n that was the exponent is now the coefficient. Well, wait a minute, we already have a coefficient, so you multiply them. So 2 times 5, we're bringing the 2 down, 2 times 5 is 10. You decrease the exponent by 1, which makes it x to the 1, and we don't usually write 10x to the 1. I'm just showing you what happens with the exponent. We decrease it by 1. So normally we would just write this as 10x. Okay, you're going to love taking derivatives of polynomials because they're like super easy because of this, right? So then we can start stringing these together. All right, what if I have a function that is g of x equals 3x squared minus 4x plus 7. Okay. Well, then g prime of x, well, let's see. If I bring the 2 down and multiply by 3, I get a 6. And then I've decreased my exponent by 1, so x to the 1 is just x. Okay. What about this one? Well, my exponent is a 1, so I bring that down and multiply it by 4. So I get negative 4. And then when I decrease this 1 here on the exponent by 1, it becomes x to the 0. And what is x to the 0? 1. Anything to the 0 exponent is 1. So this one becomes negative 4. Hey, what about this last one? This last one doesn't have any x, no variable at all. Well, this one's easy. The constant of a derivative is very easy to figure out. Let's see. I ended up not using this one. Let's just go to blank graph. Here we've got the function y equals 7. Think about the tangent line. What would the slope of the tangent line be for this line? Well, the tangent line is the line itself. It's just a horizontal line. Take the tangent line at any point. It's just the line itself. It would have a slope of 0, which makes sense. What is the instantaneous rate of change at any given point? What if this was your bank account? You had $7 in your bank account. What's the instantaneous rate of change? 0. It's not changing at all. So the instantaneous rate of change is 0. The derivative is 0. So it's really convenient to note the derivative of a constant, just a number, is 0. So, and we wouldn't write like plus 0. This is the derivative. 6x minus 4 is the derivative of this thing up here. So if you got confused along the way, that's okay. But as you can see, you'll get this, and you'll go, oh, actually, derivatives of polynomials are easy. Give me a bunch of those on the test, which I'm going to give you a variety of derivatives on the test. But this is, you'll be glad for the polynomial one because you pretty much shouldn't miss it. Okay. So then you'll see all these different examples. The power rule works for negative exponents as well. You would bring, like, watch. So if you start off with, which one's this? Part C, t to the negative 3. You bring the negative 3 down in front. You decrease the exponent by 4, you get negative 3t to the negative 4. It works exactly the same way. So, you know, nothing weird about that. Do remember rules about your exponents, right? One of the things you're going to want to generally do is convert things to rational exponents when you can. So remember that the square root function, let's see, over here, the square root function, oh, it's kind of off screen. Let me go to the next page. We might have it here. The square root function's square root of u, that's the same as writing u to the 1/2. Do you remember that when we did rational exponents in algebra? I see students a lot of times they're staring at the square root and go, I don't remember how to do this. And then you go, rewrite it as u to the 1/2. And then they go, oh, and then I just used the power rule. Right. Use the power rule. So you have to be comfortable with your rules of exponents. Again, I'm not testing you directly on your algebra knowledge, but if you don't have that algebra knowledge, you can't do these problems. It's like it just doesn't work. You have to remember, oh yeah, negative exponents, I move to the other part of the fraction. Rational exponents, all that kind of stuff comes into play. So if you've forgotten how to do that, go back and look at them. That's a multiple property. We don't need too much there. The sum and difference properties, this is another thing that makes it convenient for derivatives. If you have a function that's made up of different types of functions, you can just differentiate one piece at a time, right? So for instance, that's what I did here. I just looked at the individual terms of this derivative and I differentiated them one at a time. That's what this rule here allows us to do, is break up a function into its individual pieces that are connected by a plus or minus and take the derivative one term at a time. That's especially helpful if, like, maybe your first term is a polynomial term and your second term is a logarithmic term. Well, those have different rules about how to take the derivative. So you take the derivative of the first term using the polynomial rule and the derivative of the second term using the logarithm rule, and then it's actually pretty straightforward. Oh, I did forget to take roll. I'll do that in a minute here. So I'm trying to get all this information in since the next time I see you, we're going to be going over it. So sum and difference property. You won't, some of these rules you won't even think about. They'll just become so natural for you. You'll just do them. Yeah, instantaneous velocity. Okay, so that's those. Let me go over just real quick that marginal stuff because it's one of those things that seems confusing, but if someone kind of shows you how it works, it's not too bad. So chapter 2, 2.7. Yes, let's go over here. So if you give me a few more minutes and I can, it'll be helpful to you on the test if you stick around a few more minutes. So marginal cost, marginal revenue, marginal profit, it's just the derivative. So we go, why do we give it a special name? It's just people, and they want to say the derivative, I guess, in business. They want to give it a special name. So if you've got cost, your marginal cost is the derivative. If you got revenue, marginal revenue is the derivative. If you got profit, marginal profit is the derivative. Now, why would we do that? Well, let's see. Did they give it in a definition here or a box? Yeah, marginal cost versus exact cost. This is another one of those problems I'm telling you right now will be on the test. So marginal cost and exact cost. If C of X is the total cost of producing X items, so that's the actual cost, the real world cost, then the marginal cost function approximates the exact cost of producing the next item. We're calling it the X plus first item. If you have the cost for X items, that next item, the marginal cost tells you that because it's your rate of change. If your cost function is changing, the marginal cost tells you that rate of change. How much is your next item going to cost to produce? In the real world, most cost functions change depending on how many units you buy. If you buy more of something from somebody, they're more likely to give you a better price per unit. Okay, so your costs change over time. And you might want to know, what's the cost of producing the next item? Because you might go, our business is really good, let's up production. But sometimes what happens, like if you're using rare earth metals in computers and all of a sudden the prices of those go up, producing one more item might cost more than the revenue for that next item. Well, then you're losing money by producing another item. But we can calculate the exact cost of that next item, and it takes a little bit of algebra to do. Or using the marginal cost, we can very quickly estimate it. And it's a good estimate. So it'll give us an idea, what's the marginal cost? What's the approximate cost of producing one more item? Okay. So this problem in the book, cost analysis, example 1, basically you will have a problem on the test like that. So know how to do this one that's on page 163. You will be doing a problem like that on the exam. Okay, so that's the third one that I've told you, like, you will see this problem. I mean, I'm going to change the numbers and give you a different function, but that's literally what I'm going to do. I'm going to take this problem and just change the numbers in it. And like maybe it's not tanks, maybe it's like phones or something. But this, you will be doing this. So you've got find the equation of a tangent line at a certain point, calculate the derivative using the definition, and this one here, this cost analysis example 1 problem, you will have a version of all 3 of those problems on the test, guaranteed. It will be there. So basically know how to do them so you get it right. And if you don't know how to do them, come get help. Come ask me questions and I can help you out with it. Okay, and there's a few examples in here where you do the exact cost. Actually, let me double check. Maybe I wasn't reading closely. Is this the one I want? This is basically the same problem. I might write it like example 2. I'll have to see when I'm writing it down, but like know how to do example 2 as well. It could come out either one of those ways. Okay. And then you can see you've got your price demand equation. So then it's a real businessy type question. I mean, this whole section is very businessy, but I would encourage you to work through that example 3 as well, just to give you an understanding of how this stuff works. And I could ask some of these other questions on the test as well, but you'll definitely be asked those 3 that I just told you about. Anything else I want to say? I think that pretty much covers it. Understanding this picture, hugely, hugely helpful, right? If you can start to make sense of this, it's really going to help you figure out like what all of this stuff means. And if you're going into a businessy, business, economics, accounting, any of those things, you should be able to understand this picture. And if you can't, that's okay, but get to understand it, because these are all pretty basic ideas here with these break-even points. Here's where your profit lives. In these regions, you have loss. If you kind of can't piece this together, you're just kind of wandering blindly around these concepts, okay? So you want to make sure you understand that. Okay, with that said, let me take roll quickly here. Let me see what we got. Thanks for your patience. I just want to make sure I give you the information so that you can prepare for next week and then use that week to prepare for the test. Okay. Oops, did my pen not write? What just happened? There we go. I have a couple Maganas, but I don't have a Nancy. Is Nancy, are you Alexis or Monica?
Yeah, they posted in the chat. I think they're usually going to Alexis.
Oh, okay. Thanks. I missed that. Um, And I'm gonna have to. I'm trying to get through all that material. I forgot to take roll here. Let's see, Dylan M. Okay, this is good. We're seeing pretty good attendance. That's really good. So when I start seeing students not show up, um, those grades just plummet for those students in this class. It's super important. So keep that up. That's good. Okay, I think I got everybody. So let's see, who am I missing? Thought wasn't Joshua R in here at some point? I thought I saw Joshua R somewhere, didn't I? I miss it. Anyways, let me know. Joshua R, Rebecca S, Stella V. Guess I should look in chat here too. Oh, Joshua R. Okay, I thought so. I thought I saw that name and then somehow I missed it on the roll. Stella V. Jocelyn B. Are you around somewhere? Carla C. Dominique D. I got everyone else. Nadalyn L, I think, isn't around anymore. Okay, thanks for sticking around. I know I kept you a few minutes late, but I just want to make sure that we're sort of setting ourselves up to be successful on that test. You really don't want to take the retake because it's going to slow you down from learning the new material, right? If you can choose to study for a retake or not study for the retake, it's better to not study for the retake, right? So be ready for that work through stuff. You're going to have questions. Please come to my office hours with those questions. Don't be intimidated. Don't be scared. Don't be lazy. Come to office hours, get my help. The tutoring center will be able to help you with all of this stuff. So the tutors in the tutoring center are available to you for help. I think they will be doing, certainly next week, I believe they'll be having in-person tutoring. I think as of today, I think they still have online tutoring. So you can get some help with that. So make sure you're getting help. This kind of calculus stuff is not stuff that you can just do quickly. Like, a lot of times students think they're going to just cram for a math test and like, I'll put it off, I'll learn it all at once. These concepts are big enough that you're not going to learn it all in an evening. Certainly not understand it in an evening, right? You might learn how to memorize how to do a few of the problems, but you won't really understand it. It's a marathon, not a sprint. You want to work on it a little bit every day, and then by 2 weeks from now when you're taking the test, you'll have that really foundational understanding of calculus that allows you to ace it. And you walk out of the test, you're like, man, that was easy. And you look around, a bunch of other people are super stressed out because they took a different study approach. And they didn't really understand what was going on. So please do that. Don't try to do this in short, one evening. I'm going to do 5 days worth of calculus. Your brain just can't learn that much. Your brain, research shows your brain is technically not a muscle. It's an organ, but your brain acts like a muscle and then it gets fatigued. and after a certain point, your brain stops forming all those little neurons that happens when you learn, and that's why some students will come and say, I did all of this last night, and like today I don't even remember any of it. That's because you were in that exhausted zone and your brain stopped forming the neurons, so you don't remember how to do it. You want to be fresh when you're working on it and build on it, and then your brain's going to remember how to do all that stuff. Okay, so treat it like a marathon, not a sprint. Thanks everybody for sticking around. I appreciate the extra 11 minutes. I think it will benefit all of you. So that's good. I will keep Zoom open in case anyone wants to talk to me. Otherwise, make sure you come to those office hours and get help. Okay, thanks everybody.
Have a good one.
Yep.